Good morning, friends. Today we'll cover chapter 4, create RDD using parallelized method. So parallelized collections are created by calling JavaSparkContext parallelized method on an existing collection in the driver program. So collection can be a list as we checked in our first program example. The elements of the collection are copied to form a RDD that can be operated on in parallel. Now, one thing very important here is that as we have seen that these parallelized collections are created and the RDD is created in the driver program only. So this parallelized method to create this RDD is more actually of a POC type of thing where only for tutorial purpose and all, because it actually in the real world, we are dealing with a big data. Big data can be a very huge file in size of terabytes, or a huge MongoDB data collection, or a very huge like bucket, S3 bucket, from where we are actually getting the data. So that we will cover in the next part, that how to load that huge data set into Spark. But just for the POC purpose, just for this tutorial, we'll use parallelized method to create RDD. But what I wanted to point out is that in the real production world, we don't use parallelized because it only creates in the driver program. In the real world, it's more about how we actually get the big data from a huge data set. So let's take this example, right, where we had a list of only like 8 integers, and we created an RDD by calling the parallelized method on the Spark context on that data. If we try to visualize it, we can see that we have got a list of data, right, in this form, in the Java heap 1, 2, 3, 4, 5, 6, 7, 8, and then we call parallelized method to create an RDD. Now, as I have in my laptop, I have got 4 cores, and in our program, for example, we are using this master as local star. By local star, it means that whatever number of CPU cores that we have, that number of partitions would be created by default. And this number of partitions we can also override by when we create a parallelized method, which we'll discuss next. But let's check about the whole procedure. So suppose we call this parallelized method and our RDD is created. Now because I have got 4 CPU cores, that's why there would be 4 partitions here. And for all these 4 partitions, all the data would be split accordingly. For example, just for this example, it can be like have 1 and 2, the first 2 elements in partition 1, similarly 3, 4 in 2, and 3 and 4 accordingly. And based on the number of partitions, whenever we call any transformation method or action on this RDD, then each of the partitions would be having each task, one task a separate task for each. As we had discussed in our previous video on Spark UI monitoring, we have noticed that the number of stages are created for each of the actions, and each action would be having number of stages, like it can be 1 stage or 2 stages, depending on whether it's a wider transformation or a narrow transformation. If it's a narrow transformation, then there would be only 1 stage created. And in that 1 stage, there would be 4 tasks based on the number of partitions. So this is how all this allocation happens, and this is how the Spark works internally. Now let's go back to our to our page here. So as mentioned that once we create this RDD, we can call various operations on it like reduce, map, etc., which we already covered in our first program. And one important parameter for parallel collection is the number of partitions to cut the dataset into. This is what we just discussed. Spark will run 1 task for each partition of the cluster. We may want like 2 to 4 partitions for each CPU in the cluster. Spark tries to set the number of partitions automatically based on our cluster, as we just discussed again. But we can also get the number of partitions being used by calling this method myRdd.getNumPartitions. And also we can just customize it. So if you are like 4 CPU cores, but we want like our data set is very huge and we want more than 4 or less than 4, accordingly we have got this overloaded method in Parallelize where we can pass the second parameter as the number of partitions. So for example, if we just have this sc.parallelize data 10, it means that instead of creating 4 partitions, it will create 10 partitions and split the data accordingly. And besides that, there is another feature that we can also create empty RDD, but in the real program, I didn't find any use of it. But it's just like we have this feature to create an empty RDD as well. So enough of theory now. In the next video, we'll dive into IntelliJ and write some unit tests to understand this better. So see you all in the next video.